So 5.7, inverse trig function integration. So we have 3 integration rules, and then we're done with integration rules. Ready? Here we go. Thank you. So we have 3 integration rules. You'll notice these will be the last 3 integration rules for the year. I think it's 385, right? I'll check. I think page 385 has all the integration rules we've learned this year. All right, let's just integrate. That's what we're doing today. When I do these, I look at them like A's and U's and stuff like that. I go through the process. Okay, can I rewrite this with positive powers? You know, can I use the anti-chain rules? And so, I mean, do we have those? Can we make a U substitution? Really quickly, if I make U 4 minus x squared, du would be negative 2x, right? I don't have a negative 2x anywhere to substitute, right? So I just stop with the U substitution, and I go, well, it's probably going to be one of those trig ones then, okay? And it's going to be. This would be like a squared minus u squared, right? Excuse me. In this case, a is, what, 2, I think? A is 2, u would be x, right? And then du would be dx. So in a sense, we would have antiderivative du over 2 squared minus u squared radical. And that's the sine one, isn't it? So that would be arc sine of u over a, right? If you don't remember, go back and look. What was the sign? Yep, u over a. U is x, a is 2, then plus c. And that's it. So usually you'll see a pattern here. If there's just a whole bunch of stuff in the denominator, it's probably going to be one of those trig function ones, the arc sine, arc tangent, arc secant. Do we have to write it like this? Not necessarily. You could just write like this and say x squared and just go straight to this. Okay. All right. Let's see here. This looks like a tangent one to me. A lot of times I try and do like a u substitution, but there's still this pesky 2 here. I wouldn't have 18x anywhere, so I just stopped trying to do a u substitution and think, okay, this is going to be an arc trig. Let's see here. A, because this is a squared. 2 is a squared, so a equals square root 2 then. This is u squared, so u would be, if I take the square root of 9, that's 3. Square root of x squared, that's x. And then du equals 3 dx. And so 1/3 du equals dx. All right, so we can rewrite our antiderivative. We got du, 1/3 out in front. And then we have square root of 2 squared, and then 3x quantity squared. There's blank. Can I just go straight to the this u and a quantity squared? Yeah, but you'd miss out on that 1/3 though. Okay, so this is a tangent one. Now we gotta look back. Okay, what's tangent? Arc tangent. Arc tangent is 1 over a arc tan u over a plus c. So 1/3 times 1 over a, right? 1 over radical 2 arctan u over a, 3x over radical 2 plus c. Now this is kind of annoying because we should rationalize this. A lot of times they actually don't. They just leave it like this. But know that we might need to rationalize that, right? And that's pretty easy, right? Rationalizing denominators. Okay, questions on this? I think learning the pattern is going to be the toughest part. And then we have this one. All right. So it looks like this would be the u. The u would be the square root of this. That would be what? U equals 2x. Du equals what? X dx. Oh. 2 dx. Okay, what's a then equal to? 3. Okay. Now, let's see here. With our rules for the arc secant, this and this have to be the same, right? Okay, let's see what happens. See what happens. Okay. So we'll have what? 1/2 du equals dx. So I have a half out in front. I have my du here. I have my square root, and then I have 2x squared, quantity squared, minus 3 quantity squared. We still have an x out here. So how do we take care of that? I guess I could put u squared right here, right? Did I do that before? Not really. What about this? Well, think about it, guys. If I brought this 2 in here, wouldn't it be the same then? Right? So then we do have a u and a u. Okay, if that does not work out nicely like that, then you got to adjust this. Okay, and have to match this. Just in case I'm going to have like a 3x out here or something like that. Maybe bring 3 out in front. Okay? So anti-differentiation of this. And again, I could make this u squared, 3 squared. We could do that. That's fine. But not necessarily have to all the time. Okay, what is the rule for the arc secant 1? 1 over a, so 1 over 3 arc secant. And then its absolute value u. Our u is at 2x over a, which is 3, and then plus c. Does that make sense? Are we okay with that? I didn't take too many leaps and bounds by doing this, did I? Did I confuse you guys too much? Alright, before I used to always write this as u and then a, and then we just look over here and then substitute back in. I'm trying it this year by writing it this way. But now, like Mr. Holland said when he was over there standing doing something, changing things up is kind of difficult. This one's not too bad though. So what type of trig anti-differentiation do you think this is, just by looking at it at first? Looks like arc sine. Okay, let's see what happens. Okay, this would be e to the x power quantity squared, wouldn't it? Okay, so let's rewrite. So that'd be our u then. Our u will be e to the x power. That means du equals e to the x dx. What? That means dx is 1 over e to the x power du. And are we okay with not writing out a? A is just 1. We okay with that? A squared. I said not doing it, then I did anyways. All right, so right now what we have is this. We have du on top. Antiderivative. E to the x in the bottom now because of this, right? And then we have square root of e to the x quantity squared minus 1 quantity squared. Is that an arc sine one? That looks like an arc secant one, doesn't it? Okay, so at first it looked like there's probably maybe an arc sine, but fun fact, arc sine would be backwards. It'd be a minus u. A squared minus u squared. Okay? So be careful of that. At first looked like an arc sine. It actually is an arc secant, and not too bad. A would be our e to the x, or a would be 1, I'm sorry, u would be e to the x. So we'd have 1 over 1 arc secant of absolute value u over 1 plus c. Okay, 1 over 1 is 1. Do we need the absolute value over e to the x, around e to the x? E to the x is positive always, right? So we don't need it. And then plus c. Questions on that? Good? All right, last one, I believe. No, I'm bad. My bad. Got 2 more. Okay, I take a look at this problem. I'm like, okay, let's make the radicand, which is the stuff inside a radical, that make that our u. That means du would be negative 2x. And we got a whole bunch of extra stuff in the numerator, don't we? However, there is 1 term in the denominator. Let's split this up. To the term from x over square root 4 minus x squared dx plus 2 over square root 4 minus x squared dx. Let's see here. This right one, it looks like an a squared minus u squared situation, right? Put this constant multiplier out in front, that's fine. So this looks like an arc sine one. Now what about this one? Well, do what? Normal u sub, yeah. U equals 4 minus x squared. That means du equals negative 2x dx. Ooh, we have an x dx divided by negative 2. And that works out fairly nicely. Over on this spot, I'm just going to mark down like a equals 2 and u equals x, right, for our anti-differentiation. Okay, rewriting now. Negative 1/2, antiderivative, du, 1 over square root u. And yeah, you could have just made that a u to the negative 1/2 right away. That'd be fine, guys. Plus, I'll just go like this. I'll move that 2 out in front. 2 times 1 over square root 2 squared minus x squared dx. So negative 1/2. All right, this is u to the negative 1/2, right? So add 1 to the power, u to the half power, divide by the new power, which means multiply by reciprocal, times 2. Plus 2, this is definitely an arc sine problem. An arc sine is just u over a, x over 2. And then plus c at the very end. Okay, let's substitute back in for u. Negative half times 2, that's a negative 1. Square root of whatever u was. U was 4 minus x squared. Okay, so square root of 4 minus x squared plus 2 arc sine of x over 2 plus c. How are we doing on this one? Not bad? Alright, so if it looks like an arc sine function, arc secant or arctan function, but there's two items in the numerator, split it up. This is one term in the denominator. All right, last one. What about this? Everybody's favorite, completing the square. Now, in this situation, guys, you can try all you want to bring the terms in the denominator up to the numerator. It doesn't make like each one of them, like this is not x to the negative 2 minus 4 x to the negative 1 plus 7 to the negative 1 power. You can't bring these up individually. Why? Because it's a sum or difference, right? These are 3 different terms. If it was a product, that's different, right? Now, what we have to do is create this situation, create one of these patterns. I'm going to tell you what, it's always going to be this one. Okay? Right? Because do you guys see a square root anywhere? No, it's going to be quantity squared plus quantity squared. Now, how do we do that? Complete the square. Okay? So, let's see if we remember how to complete the square. I put the plus 7 right here, right? Now, there's no equal sign to move that 7 to the other side, like you might have done it before. All right, take your b term. That's your b term. Divide by 2, which would be negative 2, right? Negative 2 squared, which is 4. So I'm going to add 4 right here. But to not change the quantity of the denominator, I also have to subtract 4. I'm adding 4 over here. I'm also subtracting 4 over here. So essentially, you're adding 0, right? But we're grouping our numbers with purpose. Okay? Does that make sense? All right. So it's a little different when you guys had like x squared plus 4x and equals negative 7. Well, I don't see equal sign over here anywhere. All right? We can't move something over here and then add 4 here and add 4 here. Can't do that. Okay? So now since we did that, the whole idea was to create a square term, which we have right here now. This is now a square term. If we factor this, that would be x minus 2 quantity squared, right? Plus 7 minus 4, that's 3, I believe. So that's our derivative dx over x minus 2. What is going on there? No idea. Quantity squared plus, instead of 3 squared, or 3, I'm going to write square root of 3 squared, because my a term is square root of 3. This is definitely a u squared and a squared problem now. Okay, so my u equals x minus 2, du equals, oh, it's a linear function with coefficient 1. So that's pretty easy then, right? So as long as this is a linear function with lead coefficient 1, the du dx is synonymous. Okay, so, all right, this is definitely arctangent. Arctangent would be 1 over a, 1 over root 3, arctan u over a, and then plus c.